So we are going to start with the inside of the notes, and you have places to write all of these pink words down. So you go ahead and pause the video while you write those down. This should be review, but just so that we're all on the same page. Positive correlation is that they're going to increase or decrease together. Negative is that one increases when the other decreases, and no correlation is when they have no relationship to each other. We're going to do some examples so you have something to write down in the example box. So if you think about the number of hours you work and the amount you earn, if the number of hours increases, the money you earn would also increase. So that makes it a positive correlation. The population of foxes in an area and the population of bunnies. So if you think about the foxes increasing, they would eat more bunnies, so the bunnies would decrease. Sad for the bunnies. So that would be a negative correlation. The number of pasta dishes eaten and the number of cars on Highway 290. Think about the pasta dishes increasing. If you eat more pasta, it doesn't really affect the cars on 290. And if there's more cars, it doesn't affect the pasta. So this would be an example of no correlation because those two things are not related to each other. The number of calories burned and the hours walked. That one's written backwards anyway, so we're not going to use that one. And the availability of smallpox vaccine and the number of smallpox deaths. When the smallpox vaccine became more available, the smallpox death went down. So that would be a negative correlation. So where you have an example place, I would suggest writing these three because these are the best three. Write down those as your example of the different types of correlation. Now we're going to take a look at the graphs that are right next to that. And so you have these already, that these are all positive correlation because they're going up. These would be negative correlation because they're going down. And this would be no correlation because it's all scattered about. So you're going to go ahead and label them as their strength of correlation. So when they are in a perfect line, it's called perfect correlation. When they're pretty close to the same line, it's a strong correlation. And when you can tell that it's positive, but they're kind of scattered about, that would be a weak correlation. So you can see as you progress, the dots get closer together, closer to a straight line, and that's what makes it. That's the difference between the weak, the strong, and the perfect. So go ahead and label those on your notes page. And now if we kind of tie it to a situation with the graph, we have an average daily temperature at the beach and we have visitors at the beach. So as the temperature gets higher, the visitors gets higher. So this would be a positive correlation. As this increases, the visitors increases. This is definitely more on the weak side than the strong side because they are a little bit scattered about. But there is a definite association here. On this one, the hours of exercise per week, as that increases, as we move this way down the graph, the resting heart rate decreases, which is what makes this a negative correlation. This would be stronger than this one. The dots are closer to being in a straight line. This is called a trend line. I believe you already knew that. But if not, this is a trend line. The trend line shows you what a perfect correlation would be. And so it's kind of the average between all the dots. So this is where all the dots should be if it was a perfect correlation. So if we were to draw a trend line on this one, that's a really bad line. The dots are a little bit further away from the line, which makes this a stronger correlation than this one. So then if you look at your other page of notes, the little half sheet, two pieces of data can be correlated. Correlated means related. So where you have a place underneath correlated, there's a line, I want you to write related. But just because they're correlated does not mean that one causes the other. So that's the definition of causation. That one causes the other. That's causation. So we can have two things that are related but not necessarily have causation, meaning that one causes the other. So the correlation line should say related. The causation line should say one causes the other. So here's a great example. There's a positive correlation between the pairs of blue socks owned and the baskets made in a game. Apparently, athletes who have more blue socks tend to make more baskets in the game. However, the number of socks you own does not cause you to be a better basketball player. So even though they are related, the socks does not cause you to make more baskets. Here's another example. Going to the hospital can be positively correlated with being sick. In other words, the more you go to the hospital, the more likely you are to be sick. However, going to the hospital does not cause you to be sick. So chances are, if you're at the hospital, it's because you're sick. But when you go to the hospital, that does not cause you to be sick. The number of firefighters at a fire can be positively correlated with the amount of damage done to the building. So the greater the number of firefighters, the greater the amount of damage. However, the number of firefighters do not cause more damage. So it's not that the firefighters are showing up and causing the damage, but if there's more firefighters, that's positively correlated to how much damage there is. Sunglasses sold and ice cream sales, they have a positive correlation. More sunglasses are sold, more ice cream sales. Probably because it's hot outside and it's sunny, so people need sunglasses and they want ice cream. But people don't buy sunglasses, which causes them to buy ice cream. So the sunglasses does not cause the ice cream sales to go up. They're just related to each other. So here's a couple more examples, and then these examples are on your half sheet. So the number of cold days and the amount of hot chocolate sold. This would be an example of correlation. The cold days does not cause the chocolate sales. The number of miles driven and the amount of gas used. This would be causation, because the gas you use is directly related and is caused by how many miles you've driven. The age of a child and his shoe size. Those would just be correlated. Typically, as you get older, your shoe size gets bigger, but your age does not cause your shoe size, meaning that I can't say that every 5-year-old has the same shoe size. The number of hours worked and the amount of the paycheck. This would be causation, because the amount of your paycheck is caused by how many hours you work. On the back of that little half sheet, I showed you to number it 1 to 5 real quick. And you're going to write true, false for these 5 statements, and then you're going to have to put those into your feedback form. So number 1, if there are fewer than 15 rocks in the bag, then the weight is less than 40 grams. So find all the rocks. If there's fewer than 15 rocks, look at the weight less than 40 grams. And then look at these other 4 questions. I don't need to read them to you. You can read. And then you'll put those into your feedback forms just so I can see how you're doing about reading a scatterplot and interpreting a scatterplot. But that's it for today, so I will see you tomorrow.